Thank you so much for kind introduction. Actually, this workshop is really amazing and I really enjoy it. And it's a great honor for me to present NAVER Labs technology in here. So as Martin mentioned in this morning, NAVER is the #1 IT company in Korea. And actually NAVER is the only company that successfully protect their domestic market from the global search engine war. Actually, if you are Korean, it's really hard to go through a day without using NAVER service. Actually, the size is a little bit limited, but we have search engine, we have mailing services, and we have map service, which 30 million people are using the map services. And we also have a LLM service, the hyperglobal. And for the global market, we have a line messenger. More than 200 million people are using that. And we have a webtoon service as well. And then for the researcher, in very diverse portfolio, it's really good for a researcher because company has a lot of data. I mean, yeah, you have the variety of data from the map, from the finance, and from the real estate. A lot of data can come to us, and we develop very good algorithm, and we enhance the service. And that's what we are doing. So NAVER Labs is NAVER's R&D subsidiary, working on future technology of NAVER. We have 2 offices. The one headquarters is located in South Korea, southern part of the Seoul. And then the other one, NAVER Europe, you are here in Grenoble. In 2017, NAVER Labs Europe was founded by following NAVER's acquisition of Xerox Research Center in Europe. Those are our actively working research area: digital twin, AI, platform engineering, robot, XR, 5G, and even autonomous driving. And excellent researchers from more than 25 countries are working on this topic. And the reason why we are doing this is to connect NAVER's service, which was originally from the PC, now it moved to the mobile, but we want to expand it to real physical world. Our goal is to expand NAVER's service platform into the space where we live in. In order to do that, we think that the most essential technology is the digital twin. There is a different and various definition of the digital twin, but our digital twin is machine-readable map. So, yeah, the machine we are talking about is smartphone, robots, and autonomous vehicle, and even for AR glasses to understand the space and the environment where we live in. So we create the digital twin. And now, with ultra-low latency communication, we can place the digital twin data onto cloud. And not only for that, but also we can also place the AI to the cloud so that robot can understand the environment very smoothly and powerfully. So as a result, NAVER service platform can be extended to the physical world. And we are thinking about robotic services and autonomous driving services and XR services. So recently, physical AI has been receiving huge attention in the tech community. And we started this physical AI back in 2016. NAVER's first robot was a mapping robot, the M1 that was just pop up. And a device to build machine-readable map or digital twin. And since then, we improved our mapping device. So now we are using T3, which can be held with our hand, or we can place it on the wheel leg robot to mapping the complex environment. This is an example of our mapping result. It's an international airport of Incheon International Airport. It was like 6 years ago. And it's a really huge place. We scan like 7 consecutive days and processing entire 2 or 3 weeks, and then we get that beautiful map. and we can do mapping the outdoor too. Sometimes our client asks us to map abandoned cave. So that's something we are doing. So actually the biggest screen is from the small one is from the movie Prometheus, and then we did a similar thing. We mapped the abandoned cave, and that's the result. And it looks like quite nice, right? Even with the dark and featureless environment, we can generate quite good map. And this video shows the digital twin created with our robot and devices. While we creating digital twin is important, but there's one more technology we think required to make it truly usable. That is localization. Just as GPS help us to navigate or find nearby shop and restaurant based on our location, it's extremely important for robot to accurately know their location. For this, many years we've been developing a cloud-based visual localization technology, and then I will give you some video.
Localization is one of the most important spatial intelligence technologies. However, there are many everyday spaces where GPS coverage falls short, and laser scanners remain costly. With the AI technology developed by NAVER Labs, a single photo is all we need to identify the current location. This is visual localization, or VL for short. First, we need a digital twin replicated from the real-world space. From there, features like corners, points and patterns are extracted. Then, AI compares those features with the photo to estimate the location. Here's the actual demo. Even indoors where GPS fails, VL instantly determines the location once a photo is taken. It is very fast and accurate, done within 0.3 seconds, with 15 centimeters and 3 degrees error margins. There's no need to worry in the dark. VL works smoothly outdoors through day to night light changes, as well as weather and seasonal changes.
Yeah, with this mapping device, we can scan a large theme park in Seoul named Lotte World, and both indoor and outdoor. Actually, we scan like 2.5 hours to scan both indoor and outdoor. We process it like 10 hours, and then we can create a 3D map like that. And then our designer to design a 2D and 3D and routing map. And by the day 3, we can have a fully functional AI navigation service like this. So actually, this is an POC, but actually this is really the evaluation of this POC is really good. So now it's a real world service right now. Actually, the AI navigation at the Lotte World launched like 2 months ago, and thousands of people a day using that service. And this technology also has been applied to neighbor map. And here you can see one of the most complex indoor space, the coax. You may heard of it. And then user uses our AI navigation to find their destination. So again, thousands of people are using the AI navigation in a day. It has been also deployed in smart building, the Tokyo Midtown Yaes in Japan. And when you go there and with our application, you can see that beautiful golden flowers and the butterfly, and you can take a picture in front of the virtual environment. And you can do some kind of game in the restaurant area. This technology can be applied to many applications. When you go to Korean National Museum, you can download their app and you can view the artifact, and then you can have your position. You can see the artifact with the virtual content, and then also hearing from the explanation. And another important application is indoor and outdoor mobile robot. Since 2017, NAVER Labs has developed various service robots. The first model we have, the Around B, they carry the books from the bookstore, and it has a low-cost LiDAR, but it depends on LiDAR localization. Ever since 2018, we can read up the LiDAR part, so we use only camera for localize. So from 2018, we apply visual localization to a robot. And in the last one, the 2020, this one is our current service robot, Lucky. We have 100 of Lucky in 784. They are using visual localization. They call like a 2 million the query in every day. So they're providing service while doing that. So this is our service robot is localizing themselves. It has a front and back camera and send it to the cloud, and then cloud do the visual localization, and the red dot is the feature point that matches to the reference images. So this technology is not limited to NAVER robot. It can also be used for third-party robot. June this year, together with Swiss robotic company NAVER, we successfully demonstrate that our mapping and localization system can be used for their robot. And this is the place, one of the complex environment in Seoul named Bukchon, and they deliver the package, but they are like a pooping or something. Anyway, the Bukchon area is background, the famous movie, the K-pop Demon Hunter. Maybe if you have a time, you should stop by there. Maybe if you are lucky, you can see the robot. Anyway, we've been applying deep reinforcement learning to robot autonomous driving since 2017, right after AlphaGo emerged. This allowed our robot to avoid obstacles in complex environment. And this time, the digital twin was not only used as a map for robot, but for simulation environment for robot running. Actually, this is the virtual, our headquarters, and in there, we are doing a lot of robot service simulation. And this is the elevator simulation, and this we can make a synthetic data from the simulated world. And in this scene, NAVER employees are trying to abuse our delivery robot. Honestly, I wasn't too surprised to see the robot smoothly navigate between them. But we've been seeing a lot of times there. But what really surprised me that the guys holding him more than 2 minutes. Yeah, it was really a surprise for me. And NAVER Labs has been an early adopter of the reinforcement learning for autonomous robot navigation. But today, we move on to next chapter. Yeah, we are now one of the first company to apply foundation model to robotics. We began working on foundation model as early as 2021, when the term was first introduced as Stanford. Since then, we have transitioned our 11 robotic-related projects to foundation model, and across 3 keywords: vision, action, and interaction. And the 11 robot foundation model project will evolve into a single multimodal general foundation model. As I said before, we have a lot of different domain of service. We can gather a lot of data from that service, and from that data, we train our foundation model and merge into one that is our master plan. So this will enable us to handle complex and diverse tasks and ultimately create much more smarter robots. One key area of this research is 3D vision foundation model, and last year, everyone knows that we released the Duster. Yeah, Duster reconstructs 3D space from one or more images, even if they are not taken from one camera, or you don't even know the intrinsic of the camera, and it worked very well. And as Martin said before, we have another functionality. We keep adding functionality to the Duster. So yeah, robot can do a lot of things with the Duster and its families. And Now it's quite natural by using several images and make a 3D reconstruction is now natural for us. But back then, like 1.5 years ago, it was really surprise for me to doing that without any kind of complex 3D pipeline. And this is possible by Duster. And then everybody know that we have a lot of Duster family. The slide says it has 230 citation, but now it's 800. So far, I've shown example of digital twin, relatively small environment, indoor, outdoor, but it's small. The human reachable size of a digital twin. But we are also developing 3D scale digital twin. To cover its scale, we use 4 images from the airplane or drone to capture entire city. In 2019, we completed 3D reconstruction of the entire city of Seoul. It was created using 25,000 aerial images taken over 70 days and followed by 30 days of processing. The model can cover entire city of Seoul. It's about like 605 square kilometer, and it includes around 600,000 building, a lot of building. Okay, such a digital twin can be utilized to create flood simulation and urban planning, visual analysis, and real-time monitoring, and etc., etc. And this is the very technology that we recently export to Saudi Arabia. We are now creating digital twins of 5 major cities of Saudi Arabia, and we completed 3 of them, the Mecca, Medina, and Jeddah. Let me show you a video. Actually, this is the city of Mecca. If you're Muslim, you have to be there once your lifetime. The size of Mecca is about a little bit larger than Seoul. And we have completed the Medina digital twin, and this is the place where the Muhammad tomb is located. And also Jeddah. And normally Saudi do not have many lanes, but once it rains, it's going to be a flood. So many people die from the lane. So the Jeddah is really interesting in the flood simulation. So this kind of digital twin can be used various purposes. So for example, terrain analysis like this. Yeah, you can check your visibility by seeing the skyline of the building. And sunlight also, you can measure the sunlight even before you build the building. And you can measure the height, and you can. Okay. Yeah. Oh yeah, I know. Okay. I have to skip the. Yeah. Now it's good. Yeah, we have also applied digital twin technology to NAVER's commercial service. This includes features like compound tours and property tour, allowing users to virtually navigate the apartment complexes and listing in 3D. Although we are not actively promote these services, the user engagement has been strong. Less than a year, we scanned like 200 apartment complexes in Korea, and the number of the house we cover is nearly 100,000 units. So we have a lot of the house data, full 3D house data. We have developed the panorama mapping device and apply digital twin technology to NAVER Street View. Yes, we have Street View too. Previously, Street View service was inconvenient because it has only the images 10 meters away. But if you have a full 3D, you can attach important information onto the building, and you can attach some kind of new advertisement on the virtual space, and that's really something new. And Street View is also used in the movie. This clip is from Polaris, released on Disney Plus. After shooting in a studio, a digital twin background from Street View images was added to create highly realistic scene. So there's no building. Now we have building. On NAVER maps, the novel view synthetic technology is also applied. So enabling you to experience Korea's landmark in video-like, very photorealistic view. So when you download NAVER map, and you can find some of the landmark of Korea, 10 landmark Korea, and you can see that this kind of the very dynamic scene. Okay, so now we have obtained the technology that allow robot to move one point to another point, but this alone is not enough to commercialize or popularize the robot. The key to popularizing the robot is the cloud, with which we replace the robot's brain. Here, 5G networks are critical for connecting the robot to its brain in the cloud. 5G is known for its speed, but the most important thing for the robot is ultra-low latency. So since the latency is too low, robot might think that their brain is located internally, but in actual scene, the brain is in the cloud. So you can use powerful computation in the cloud while you're still controlling your robot. So this has many benefits, such as simultaneous upgrade and control of multiple robots, and reduced power consumption, and smarter, small-sized robot. Since we successfully demonstrate the use of 5G controlling in robot at CES 2019, even before the commercialization of the 5G network. The robot was actually connected to the computer located outside of this building by the 5G network, and then they do controlling that kind of a very complex, controlling task. With this technology, we have developed a cloud robot brain system called ARC, short for AI, Robot, and Cloud, powered by NAVER Cloud Platform.
In the near future, robots will be a part of our daily lives. And not just one or two, but hundreds, thousands, or even more. They must be smart and have excellent performance. We'd like to introduce ARC, the most advanced multi-robot intelligence system. It goes beyond a simple robot management or control system. Short for AI, Robot, Cloud, ARC is equipped with the latest algorithms and high-precision data required for human-robot coexistence. By connecting to ARC through ultra-low latency networks, countless robots can simultaneously become smarter. Its key components are ARC Eye and ARC Brain, powered by NAVER Cloud. ARC Eye is the telenosis for robots. Wherever the robots are located, ARC Eye can perform accurate localization and provide the most efficient route to the robot. This even works indoors where there is no GPS access, because it uses visual localization, an AI technology that allows localization based solely on camera images. ARC Brain is the computing system shared simultaneously by all robots. Complex brains previously had to be built inside each robot, but we can now transfer the robot brain to the cloud using 5G networks' ultra-low latency. This was made possible by a breakthrough solution called brainless robot technology. By processing movement, localization, and task performance through NAVER Cloud, we can drastically reduce manufacturing costs and battery consumption of the robot. Arc Brain also connects space and service infrastructure in real time. It understands and manages all online and offline environments between robots and humans. Arc Brain will increasingly make robots smarter by updating data and algorithms, so robots can completely be integrated into our everyday lives, something robots can't possibly do on their own. The new connection of AI, robot, and cloud begins now.
Arc was first applied at scale in NAVER's second headquarters, 7084 building. The Arc integrates the digital twin and the building infrastructure like elevators, speed gates, or automatic doors, and NAVER service for ordering and payments. So, furthermore, more than 100 service robots are connected to Arc via 5G network in this building, and working together provide service throughout the entire building. Then these are NAVER headquarters. The gray one is the 7084. Well, the 7084 is the world's first robot-friendly building. Actually, we choose the name 7084 because it was the year the first industrial revolution began. So we hope this building will be a new start for the future technology. When developing robot for the 7084 project, we conducted tens of extensive human-robot interaction research. For robot, most important thing is to understand the human. So that's why we are applying AI research, enable robot to understand and predict human behavior in 3D. From a single image or video, we can reconstruct person's full 3D in real time, so that robot can estimate posture, orientation, and distance, and interact more naturally and effectively. Based on this research, we also conducted many experiments on how robots should move around people, so they are not, the people not fear about the robots approaching. And this video showed an example to find best algorithm for controlling many robots alongside human worker. They act like a robot. Each of them are robot, and they simulate the robot behavior. So they master the algorithm so they could act just like a robot. And then finally, you can see robot in real operation. The human part turned into robot part. As mentioned, we actively done tons of HRI research, and I'd like to show you one really interesting case study.
Imagine you're designing robots that can navigate through a building. You will have to design every single robot behavior. There is a place where those problems are being tackled one by one. NAVER 1784, a giant testbed where 100 robots coexist with humans. Let me introduce you to the case study we recently published. Robots riding elevators. It sounds simple, but there's more consideration for the other human passengers. The ultimate goal is to increase people's overall satisfaction when they ride elevators with robots. The two test factors for this experiment are time and manners. How quickly should they get on? How polite should they be in choosing where to stand? Robot engineers need to prioritize. What was the result? Time wins by a narrow margin. As much as politeness is important, people cannot stand slowness in elevators, even for robots. Here is a noteworthy finding from the study. The idea is that time depends on perceived speed, not absolute speed. Though it takes the same amount of time to move, people perceive the robot to be slower than it is. When it makes a seemingly unnecessary turn or stands by for reasons incomprehensible to humans. This leads people to feel that robots are incompetent, resulting in reduced overall satisfaction. Even the single task of riding an elevator can change a robot's reputation. Therefore, we updated many of the elevator boarding rules for the robots in 1784. We even all changed the robot standing locations we initially specified. Experiments and updates are still ongoing today. because the real world is always unpredictable.
Yeah, our robot is too polite, but I was really surprised to see this robot. Yeah, this one is from China, and then it's really aggressive. They just get in. So I think that the best way for robot to get board on the elevator is probably between theirs and ours. Yeah, ours is too polite. So the app interfacing robot and human is also critical element. So employee working in 784 uses NAVER Works application for robot service, which contain all of the functionality in this slide. We can send an email with this and send message to colleagues like with this, but we can order robot service with this application. For your information, the NAVER Works is an enterprise software used by 5 million users across 500,000 companies worldwide. I'm sure you will all curious to see what the robot delivery service is actually look like, and this is the robot service in 784. Yeah, we use the application to order some item from the convenience store, and then the robot, the people, and pick and place, and then robot deliver it to your desk. And we have the world first and world only, the robot only elevator. At 784, a single types of robot provide 5 different services: the beverage delivery, lunch box delivery, and package delivery, convenience store delivery, and person-to-person delivery. Robots are assigned to one of the 5 services with peak demand throughout the day. So about 5,000 employees are currently working at 784, coexisting with our 100 robots. And as a result, we have accumulated price list data for past 3 years on the interaction between humans and robots. And we are still on the way with the smart building that operate robot service at scale. That's why over 25,000 visitors from 65 different countries are visited 784 to witness its innovation. And 784's smart building solution is now expanding to globally. The first step is at the EIS building located near the Tokyo station, this building. Robot delivery service are integrated with the robot delivery service currently doing in the EIS building, and we are fully integrate the elevator and gates and food and beverage operating system as well. While we are providing robot services in a building scale since 2022, we expanded our robot service to campus-wide, more larger area in our data center GAC. So this is our second data center, GAC Sejong. It is the largest data center in Asia. It stores like 600,000 servers, and our robot provides the service to help people to manage the data center. Actually, what we are doing there is we provide the server racking robot and pull the server from the rack, and then it placed it to another robot named Garo, and then it goes whenever the people want to come. And then another robot is an inspection robot, and this is a fully autonomous driving vehicle. So we have gained expertise by developing building scale robot service at 784. Also, we showcase campus scale robot service with the GAC Sejong Data Center, and ultimately we aim to build a robot service for smart city. In there, hundreds of thousands of robots will be exist, and they will provide millions of services there. So as presented today, NAVER Labs has developed highly advanced technology for digital twin, cloud, and AI and robot software and hardware. It could be difficult to find a company with such a comprehensive portfolio worldwide. And by the way, NAVER was recognized by Morgan Stanley as one of the world's leading humanoid company for 2 consecutive years. But however, we haven't showed them any clue of the humanoid. In fact, we have been collaborating with Professor Sang-bae Kim at MIT since 2020 for developing humanoid robot like this. And now we are doing research with the Professor Haewon Park from the KAIST for more polite and more advanced movement of the humanoid. Okay. This prototype is scheduled for functional test at 7084 in this month, maybe next year. This humanoid, we call it mininoid will deliver your package to your desk. So if you are lucky, then this one will bring your copy to your desk, or just lucky will come to your desk. That's what we are doing right now. And now I'm going to introduce one more robot, the Lucky 2. So Lucky 2 is our new service robot for smart building. Now we have actually Lucky 1 is almost 3 years, more than 3 years. So they are old. They sometimes broke. So we want to replace Lucky 1 to Lucky 2. Yeah, Lucky 2 will deploy not only in Korea but also overseas, so including Japan and Saudi Arabia. Ultimately, our aim is to make robot a part of our everyday life. To achieve this, NAVER Labs has been collaborating with various industry and academia, and will continue to do this research. So thank you for listening. This is the end of my presentation. Thank you very much.